Afternoon, everybody ready to talk V6 only? Excellent, excellent. So somebody from Liz's presentation, somebody asked for a presentation from EE, tick. And you also, well, the key message there was, even though the presentation might be dry, at least there might be some useful content in there. So let's run with that. Okay. I'm Nick Heatley, by the way, a network architect. Came from EE, now in BT. Shocking. NAT is well established in mobile networks. So I expect you all know this, but we're happily using carrier grade NAT extensively for internet services. So we tend to augment our stocks of IPv4 public addresses with the private ranges. And the mobile experience is a given there through carrier grade NAT. So that's NAT 4 today, highly successful. So about 5 years ago, we started thinking hard, long and hard. Most IPv6 discussions start well before that 5-year time span. But yeah, there we were 5 years ago looking at the private address limits. So Orange and T-Mobile had come together. We've got EE, we've got 30 million customers, 20 million privates. But it's fine, it's okay, because not everybody needs an IP address at the same time, do they? So then smartphones on 4G with LTE, you're looking at a single EE APN. It's always on. Percent of the time. So suddenly that 30 million customer limit seems to be where we're heading. But it gets worse. When you look at moving voice to VoLTE, voice over LTE, then that's another service which is IP based. So we switched on in 2014, we switched on an IMS APN. That was originally for voice over Wi-Fi, and now we've added voice over LTE, or what the brand people call 4G calling, and that's now in the network, and that's another demand for IP addressing. Now, okay, you just overlap address space. One bit doesn't need to talk to another. Well, maybe. And then the other drain on IP addresses was when you consider utmost data reliability. So obviously data now is a key service. It needs to be up 100% of the time. That's what customers are demanding, and availability is king. When you look at the resilience of that service, you want that resilience mechanism to be deterministic, and you want that resilience mechanism simple, straightforward way. So one of the plans from the network designers was to introduce larger IP address pools, so that if we were to lose our addressing systems and our policy and control systems, then we'd have IP address pools that are ready to soak up the slack. Because smartphones are aggressive little critters, and as soon as they drop off the network, they'll be back at that network asking for another IP address. Come on, let me on, let me on, let me on. And when you've got millions and millions of those connections, then it's a massive demand on the network. So we had to look at all of those requirements, and it clearly 20 million private addresses, add whatever public addresses we have, it's not really going to cut the mustard. So IPv6 was a clear deliverable. And we haven't even talked about Internet of Things, and just add more data endpoints. So kludge, it's a common word, isn't it, amongst engineering people and software people? Someone said, what on earth does it mean? Well, a compromised workaround. So can we have a compromised workaround for IPv4? There's choose your poison. Overlapping address space, layers of NAT. So the other option, of course, is to go for IPv6 and reduce your investment in NAT and the associated logging. The question there is it a complete solution? And dual stack does not alleviate the address exhaustion. So one of the key things that we pushed for was IPv6 in EE. So we ensured that VoLTE APN was IPv6 based. We didn't want overlapping IPv4 there. And we then proceeded to look at IPv6 only for data services. So meanwhile, I think this private address exhaustion problem was being looked at in other places as well. So the likes of Facebook, Google, LinkedIn, Microsoft, in their vast data centers, they're looking at the similar sort of issues with private address exhaustion. And they're at various stages looking at IPv6 only in the cloud or in the data center. And the common threads seem to be this desire for clear reachability, the peer-to-peer nature of a pure IPv6 connection, the end-to-end openness of it, the simplicity and homogeneity of an IPv6 deployment. So the question is the consensus formed that IPv6 is the only perennial solution to this number shortage? Well, we shall see. So why single stack in mobile? So mobile is quite an interesting and unique environment. And we find, and this is my opinion, that carrying two address families is a burden. So it's a burden in the radio access network, because if you've got double the protocols, you've got double the signaling. Now that got fixed in Release 8 with IPv4 v6 bearers in LTE, Release 9 for the rest of the network. So, okay, that maybe disappears, but policy, control and charging, that accounting and management of two sessions, this issue never goes away. And that's big in mobile networks. We put a lot of emphasis on the policy and control, middle boxes, and the charging there is an overhead. And double the sessions, that's a burden. If you think about the customer's device, is one better than two? One protocol, less battery drain, less conflict, looking at the two protocols, sort of happy eyeballs, trying to fix that, apps trying to work over two bearers, DNS, the additional cost of DNS if you're polling both V4 and V6. In major networks, that could be a consideration. So maybe one is better than two there, and it gives a better experience. And then just ongoing, long-term, running two network protocols. You do it for the existing, you've got to, and that's going to remain. But for new services, are you going to have to continue adding support for V4 and V6 continually ad infinitum? So there are quite a number of specific burdens in the mobile network. And so every time we can get a device to be IPv6 only, it returns an IPv4 address to the pool. So going IPv6 only, the main mobile experience challenges are around application support. So you might have heard the term IPv4 address literals. So these are where services, web programs, web servers are coded to look for an IPv4 address rather than a URL or some other abstraction. We could see them on the client side, so a traditional VPN client looking for an IPv4 VPN gateway. We can see them in apps. An example has always been the Spotify client seeking an IPv4 address of a server and not a URL. And other services can use them, PC gaming clients, the PC version of Skype. They're based on IPv4 address literals. Then on the server side, we've got web referrals and redirects, where the redirect is pointing not at a URL but an IPv4 address. Poor coding. And then user input. If you're trying to browse to an IPv4 address in your browser rather than an FQDN. So there's a solution for this, a solution that is available in smartphones today, and it's called 464XLAT, and it's standardized by the IETF RFC 6877. So before we just talk about XLAT, it's worth just capturing what the mobile use cases are that we're interested in. Voice and IMS, pretty straightforward in comparison to data. It's a closed environment, so you need to provide IPv6 across the IMS cloud to an IMS system. And then there's three flavors of data that we're interested in: data or data on your handset, tethered data where you've got another machine that's using the cellular device as a gateway, and then more specifically mobile broadband, where you might use a cellular router to connect up various Wi-Fi tethered devices. So we need to make sure that all of these can work in an IPv6-only way. 464XLAT. Here's the brain boiler. Let me try and take myself through this. So when you connect to a piece of content or a service, there's three ways that you can invoke that connection. So you can do a DNS lookup and find an A record and go to an IPv4 destination. You can do a DNS lookup and get a quad A and go to an IPv6 destination. Or you can have an IPv4 literal, basically, where an app is bound to the IPv4 stack. So there's an accepted solution for DNS-based access to IPv6-only networks, and that's DNS 6.4 placed in the DNS function. So that can synthesize down to the client. It can synthesize quad A's based on A records that it sees externally, and provide the synthesized quad A's down to the device, and the device will then connect through a NAT 6.4 gateway to get to the IPv4 only content. What 464XLAT does is provides a similar end result, but it does it using a function that resides on the handset itself, the CLAT. It fools the apps that there's a valid IPv4 stack residing on that handset. You'll see a dummy address, typically 192.0.0.4, and that address is repeated on every handset, so it's isolated. It provides the IPv4 stack for the IPv4 bound app to utilize. It then immediately does a stateless translation to turn the IPv4 traffic and turn it onto the IPv6 bearer pointing at the NAT 6.4 gateway. So the traffic then passes through the NAT 6.4, where it can be re-natted back down to be IPv4 and get to the IPv4 only content. So on the access network portion, it's pure IPv6. You only need to give an IPv6 address to these devices. So you save those IPv4 addresses. So the CLAT is a stateful function and available in a number of different smartphones, Android and Windows Phone. We've got a slide covering some of the main eligible devices there. And this function, it's great for data and tethered data. Because it's a network-based function on the handset, it will allow Wi-Fi tethered devices to receive both an IPv4 and IPv6 address on the tethered Wi-Fi subnet and translate the IPv4 traffic to IPv6 to pass over the the IPv6 network. Sorry about that. So there's a number of IETF RFCs that go into making this service. RFC 6877 is the main 464X informational draft. The handset will discover the NAT64 using RFC 7050, discovery of a NAT64 prefix, and then we've got the addressing standardization in 7335 and 7278 information on prefix sharing, which allows the tethered device to share the IPv6 prefix of the handset. So briefly, we've been putting this out on Android devices, all the key devices from 2016 onwards, some device types there, more to follow. So where are we at? So VoLTE switched on 2014, over 1 million devices on the VoLTE 4G calling. In 2016, in the second half of the year, we switched on the IPv6 data APN. It's a single APN providing both the IPv4 and IPv6 connectivity. So if you're on a legacy device and you request IPv4, you remain IPv4. If you're on an eligible device that can request IPv6 or IPv4v6, then you'll receive an IPv6 bearer. And the other thing in the mix here is the subscription. We are working on EE post-pay consumer subscriptions. So we've currently we're about 50% of the way through the updating of these subscriptions in the consumer base. So we have about 750,000 devices using IPv6 only. When we complete our subscription updates, then we expect to have over 1 million using IPv6 only on the mobile network. So what we've found with a handset on the mobile network, that from a data volume perspective, 50% of that data volume is IPv6 based, and it's increasing all the time as more and more content comes online. And then the majority of the remaining traffic is DNS64, NAT64, and then some small percentage, less than 1%, tends to be via the 464X LAT. So that's what we've built. There is an alternative IPv6 only approach emerging. So if you can provide an IPv6 only ecosystem which protects you against the occurrence of IPv4 literals, then you have a solution that works without the 464X LAT. So if you can fix the apps to work in an IPv6 only way, maybe police your app store, ensure IPv6 compliance and no literals in those apps, and try and fix the server side. Build a bump in the host approach, let the OS help repair any literals that come on the server side or within the OS, within the browser, say. And it can discover the NAT64 through RFC 7050. Then you've got a potential solution that will be IPv6 only and purely DNS64 and NAT64 based. So I don't know if that sounds familiar to anyone, but I think the potential challenge in this environment, something that we're trying to understand, is IPv6 only tethering of any device. So if you imagine a device enabled with 464 XLAT and that network solution that allows you to have an IPv4 tethered device tethered to a V6-only cellular device, to use a medical term, it's like the universal donor, blood groups. It can donate any address type to anything that's tethered to it. If you've got an IPv6-only device without XLAT, then you're the universal recipient. You can work on any network, V4, V6. You'll work happily away because you've been immunised against these IPv4 literals and their occurrence. But you might not be able to support an unknown OS device tethering to you. So that's something that needs further study. So that's it. I mean, to wrap up, IPv6 only access networks are out there. They're becoming a reality today. You need to look at your own particular network environment, but you may find that IPv6 only could offer you less of a burden going forward. It could lower your costs. And watch out for new emerging IPv6 only options. Thank you.
Okay, thank you, Nick. Any questions? Jared?
Hi, Jared Mott here. So T-Mobile in the USA did this, and I think their numbers are something like 80% of their traffic is IPv6 at this point now. Could you comment on what your traffic statistics look like for V6 versus V4?
So in terms of that V4, V6, you've got to shop around for your stats. These various agencies providing the stats really differ, especially in the early days. If you look on the World IPv6 launch website, we're somewhere around 2%. But what tends to complicate those statistics is that you've got, we've got mobile devices and fixed on the same AS. And fixed network, generally when you do the statistics, you're checking endpoints. And on a fixed network, one router might be supporting 5, 10 clients. So it tends to be weighted in that way. So in terms of our mobile network, I'd say we're probably much higher, more like 5% of traffic on V6. And it's growing, and we're going to keep growing it as we bring on more and more devices.
Tim Robinson from TXRX Comms. What are you doing in terms of firewalling your IPv6 traffic? Because effectively now your mobiles are on public IPs.
Yes, we are firewalling our IPv6 traffic. So what we've done is we've turned off the NAT function. We keep the firewall. So we have got an IPv6 firewall on the IPv6 path. So that's something that we're not expecting to lose. It's good for the customer because it removes internet crud, internet background, all the probing and just general stuff that's not solicited, let's say. But it also protects our network because every time one of those pieces of unsolicited traffic hits our network, we have signaling that needs to come up in the mobile. And we could literally bring that all the way down to the handset only to find it gets thrown away because it doesn't match the 128-bit address of the IPv6 end device. So we don't want that.
James.
James Blessing with my ISPA hat on. Has moving all these customers to V6 made RIPA requests more interesting to deal with?
No, not yet.
Okay, thank you very much, Nick.
Sorry.
Sorry.
Sorry, I just got a question.
Okay, a question from IRC.
From IRC. Do EE need slightly custom firmware in their handsets to do this, or is this a feature now being baked into standard Android and iOS?
So those handsets that are listed in the slides, you can browse them. They're going out default on IPv6 only.
Is it standard firmware?
Yeah.
Is it a standard as shipped from them? So I can rock up and just buy a SIM
So
for
the-
a standard.
So the CLAC functionality exists in Android mainline and has done since one of the version 4 OSs went out there. So it's there. It's dormant most of the time, so you need some APN settings to get you onto IPv6 only, which are operator specific. And then if that handset finds itself on an IPv6 only network, then its CLAC wakes up and it gives you that backwards compatibility.
Okay, one more question. Oh, sorry.
Ask yours. I've got a very quick question. So you mentioned 464 XLAT. What's the situation with supporting different operating systems? If you wanted to do this on a general Wi-Fi network, you have the advantage of the devices being more locked down. Do you think it's practical that on a general Wi-Fi network you might be able to deploy that approach?
So not all Wi-Fi networks are the same, are they? There's different use cases, I think. I think you need to look at the specific use case. If it's a public Wi-Fi network and you're expecting to service the basics of internet web use, I don't see why it's not a problem. I mean, so you can make the Wi-Fi connected over an IPv6 backhaul, and then you would need the 464 XLAT client within the access point. Putting it onto the end device is a bit more difficult when you've got a selection of unknown devices out there on the Wi-Fi network. And everything I'm saying here on CLAT and how it works is tied to the cellular bearer. I don't believe that this is there on the Wi-Fi interface on the same handsets.
Okay.
I've got one question someone's just asked on IRC, and then I've got something I just want to say. The question is, does your firewalling also protect IPv6 customers of yours from other IPv6 customers of yours? So two people with IPv6 prefixes on their handsets, are they protected from each other? Or does that occur further upstream in your network?
Simple answer is it's not the firewall, but
okay.
Yes.
Okay.
So it's a filter. It can be a filter.
The other thing I wanted to add is that this is actually a favourite topic of mine, and Android and 464 XLAT, how I understand it, doesn't actually, the CLAT doesn't actually work over the Wi-Fi interface. There is a bug open, and the person who opened it is actually giving a presentation here today, so I'm going to ask him a few questions about it, see if he's got an update for us on that. Yeah.
Okay, one final question from Andy there.
Hello, Andy Davidson from IXLead, others. Is there something like happy eyeballs in the mobile browser and application world that means sometimes applications resolve to use the V464 XLAT path when a clean V6 native route would have been available? And if so, is there something that this community should do standardizations wise to change how happy eyeballs works to stop this from happening?
The simple answer is that could be a factor. So it's a network solution, the 464 XLAT. It's providing a network. If your app then believes it has both a V4 and V6 path, and there's nothing to tell it otherwise, it's not tied by the OS, then that can be a risk.
that's scary because we want to ultimately turn this mungy layer off in favour of the native clean path. So is it something that you're looking out for and measuring so that the standardisation and recommendations bit of the work that this community does?
So what you're saying is, can we turn off happy eyeballs? That's really what you want. And I mean, there's a whole industry discussion about that, yes. So there should be that discussion, but we need more IPv6-only networks.
Okay. Thank you very much, Nick.
Thank you.